Okay, my name is Zbigniew Szymański. I work at Wire in Berlin. Wire is messenger application. And the nice part is that Android client is mostly written in Scala. Yeah. This is a proof that you can use Scala on Android. The talk is about reactive UI on Android with Scala, but I'm not going to talk about Scala language itself, and I will not talk about using Scala on Android. This can be done, but I will not tell you how to do that. And of course, I'm not going to tell about application development, application design, or architecture. I will only tell about doing reactive UI, using techniques which are enabled by Scala. And this technique is actually signals. If you were on the hipster-oriented programming before, that's exactly what I'm going to do now. So I will start by introducing signals, what are signals in general, and how my implementation of signals works. Because all of that is based on my implementation. There is no signals generic standard library with signals. This is using what I kind of invented. So there are edge cases. And then we will move to case study. I will show you how to create just simple control on Android using reactive UI. Signal in general is just a value that changes over time. The idea is borrowed from functional reactive programming, but my implementation is very much not functional, and it's customized for Android development. So if someone from functional reactive background would see that, they would hate me. Yeah, that's basically it. In essence, you can think about signal as just an observable. You could implement basic signal, just single interface with two methods, one to set the value and one to register subscriber on that. And then whenever this value changes, your subscriber will be called. But there's more than that. Signals are a bit like cells in a spreadsheet. Like in a spreadsheet, you can define a cell. A value in this cell can be a function of a value in different cell. And you can combine that, and you can build huge graph of dependencies between different cells. And that's exactly what signals do. Each signal is like this cell in a spreadsheet. You can combine the signals together and create huge graph of dependent values. And whenever one value changes, this change propagates through the graph and updates all other signals. We rely on that a lot, but there are many differences and edge cases that you need to know when you use it like that. Also, signals could be compared to event streams. Like in here, the blue line is a signal, and the red dots is corresponding event stream. We could actually convert signal into an event stream and convert the stream into a signal, but they are completely different. If you know RxJava, then okay, you will understand some concepts, but please forget about RxJava. We don't want to think in a way you think with event streams. For us, signal is a value, and it generates events, but it can skip events, or it can generate the same event twice. This generates quite a big difference in how you use it compared to RxJava. In signals, we really focus on final state, not on intermediate changes. Okay, let's move to my concrete implementation of signals. There are several properties that you should be aware of, and those are mostly properties of my implementation. Those are the choices that I made, and yeah, I need to live with that. First is that signal can be actually empty. And we use that when the data is being loaded or when we download something from database. Signal can also lose value over time. At some point, signal can become empty. And the most important part is that signals can actually skip some changes. They are allowed to skip intermediate changes whenever they want, but one guarantee is that the final state should eventually be transferred and notified. Like in this case, the dotted line could be actual changes in the value of a signal, but the solid line is what listener observes. This seems like very unreliable, and you may think, why should I use it if this just skips some states? But if you think about UI and modeling your UI in a signal, then you don't really need to know about the intermediate states, intermediate changes. They will just cause flicker on your screen. What you really care about is the final state that you want to display on a screen. My signals are also lazy. Lazy in a sense that signals are not being processed when nobody is listening for the change. This also applies when your view is not shown on a screen, or your activity is paused, or a fragment is removed. Then all the signals that are used in this fragment will not be being processed at all. You can have a huge hierarchy, huge graph of signals, but at any given point, only some small subset of them will be processed. And there is one big guarantee that signals give you, is that when you have this huge graph, it will be eventually consistent. At any given point, the values in signals may be weird, but at some point, all signals in the whole graph will have consistent values. That's what you can depend on. Aside from signal, we also have event context. Event context corresponds to lifecycle objects, lifecycles of different components on Android. So we have global event context, and we have context per service, per activity, per fragment, and per view. This context actually track all subscription on all the signals in this specific context, and they make sure that the subscriptions will not be called whenever the context is not active. When your fragment is paused, when your activity is paused, then it actually pauses all subscriptions. And that's where the magic happens. In here, we use techniques from Scala, mainly implicit, so we don't need to specify this context every time we subscribe to any signal. We just subscribe, and the context is taken from implicitly from the scope. And of course, we get automatic unsubscribing whenever the context is destroyed. So you don't really need to care about memory leaks. You don't need to remember whenever you subscribe to something, you don't need to clean that up. This will happen automatically. And one main thing is that all APIs are thread safe. You can use everything in signals. Actually, that's the idea. All processing should be multi-processed. When you have this huge graph, you want some parts to be executed on background. Some parts needs to be executed on UI. And we have ways to control whatever happens where, but API lets you do that from any thread. Here are some samples how you use it. Like the first one is setting a value on a signal. I use exclamation mark to kind of show that this is not so much setting a value as sending a message, sending an event. We also have atomic mutate operation on a signal. When you have multi-threaded code, you want to easily mutate stuff and make sure that this is atomic. You can also access current value from a signal, and this value, the type of this value will be optional because the signal can be empty, and you want to know about that. You can subscribe on a signal, and when you subscribe, you can actually specify event context, so thread on which this subscription should work. Like in this one, we just use method on, we pass the execution context, and we just do some operation on that. We can skip the on part, and we can just subscribe, but then we are not guaranteed on which thread it actually runs. Sometimes we don't care. We have also an API to modify signals. Like in RxJava, we have map and flat map, and they basically work the same way. So the first one is just taking the field from an object. So from one signal, we create another signal which just has a part of the value. And in the second, we compose a signal from two other signals, and it will be actually updated whenever one of the source signals changes. Okay, that was the API, and in general, how signals work. You don't really need to understand all of that. There are too many edge cases. We can move to case study. Case study, we will just create one UI control. This will be application for playing music. So we want to be able to display state, what song is currently being played, what's the progress of playback, and we want to control the playback. There are a couple of things that we need to care about. Like we need to always display current state. Whenever the song changes, we need to update the label. Whenever the playback advances, we need to change the progress. And whenever the playback state changes, we need to reflect that in our UI. And we also need to take care of edge cases, like what happens if no song is actually selected? Or what if we don't have any information about current album, we don't know how many songs there is? Most likely we don't need to do anything in UI because this should be handled somewhere outside. Maybe our UI will not be really showing, maybe there will be loading spinner somewhere. But we cannot crash when this happens. So we need to handle that kind of gracefully. We are assuming that UI is designed. UI is already in XML, layout is there, all resources are there. And we will also assume that we have this playback service ready. Playback, this is just one trait that implements all the functionality that we need. It has valued methods to get current song, song information, album information. It has methods to control the playback. And we want to just implement one view. This will be our custom view, playback view, which will use the service and will actually implement the logic under this control. Yeah, the quiz is, and I have some caps for that. How many lines of code do we need to write this view? Any ideas? You can just choose a random number. Remember that we need to handle all the boilerplate that Android code requires, right? We have a view, we need to inflate the XML layout, and we need to do everything. No, this will be in Scala. Yeah, that was very optimistic. No, the answer is 100, which is pretty. I would bet that in Java it will be about 300 or 500. But okay, and we have 100 lines of code, and I will show you all of them. So yeah, let's start with the boilerplate. This is our playback view. It extends relative layout, and it also uses this view helper. This is a trait from Scala, which provides, actually this trait implements event context. So this is the event context that we will be using, and we don't need to care about it anymore. And it also has a couple helper methods to deal with the Android boilerplate code. Like in here, I don't need to call find view by ID. So I just inject my service, I inflate XML, and I bind all the controls from this XML. First thing we want to handle is displaying current state on of our view. Displaying current state consists of displaying label for current song, and this consists of an index of a song and the number of songs in an album. We also display duration of current song and the progress position and progress bar. At first, we define couple signals. First one is current song information. We had current song signal in a service, but this was just ID of a song. And we want to have information about the song in one place. So we do flat map with song information from a service. The same with album. We take current song, we take an album from a service, and we generate one signal containing just current album information. The same way is with current position. We take current song, and we take playback position from a service using ID of this song, and we have current position. Whenever the song changes, this position will change to actually position in this song. This way we can actually save playback position for every song in our database, and when we switch between songs, we can start from the place where it was playing before. Yeah, we'll start by implementing the label. This label actually contains two information. One is index of currently played song in an album and number of songs in this album. So first we just defined song label, which is a signal. This signal uses current song signal and album information. And from that, it just computes one string having index of the song and number of songs in the album. And then we just subscribe on this signal and call setText on text view. This is like binding our view to a signal. Whenever it changes, our label will be changed. And that's it. We have the label handled that way. We can also handle duration. In here, we just map over current song, take duration out of it, convert it to seconds and to string, and we bind it to setText on duration text view. Like in this place, I didn't use intermediate value when I saved the signal. You can use anonymous signals. You don't need to keep them anywhere. Progress is a bit different because our current position was in milliseconds, and depending on player implementation, this could be changed multiple times per second. I don't know, this breaks somehow. This can change multiple times per second, and we don't want to update our UI 100 times a second. We just need to update it once a second. So we can use some throttling, or we can just use the idea of signals that when value was not actually changed, then the signal stops processing. So we map current position to seconds. This map will be executed every time current position changes. So like this function could be executed 100 times a second, but every time it will return the same value in seconds. So the position seconds signal will ignore it, and it will not notify listeners about it. So we can just convert it to string and bind it to setText. And this setText will actually be called only once a second. Sometimes can be called more often, but very rarely. The same with ProgressBar. For ProgressBar, by default, we have values from 0 to 10,000. So we also need information about current song duration. So we use both signals. We get current song position in seconds and compute the value from 0 to 10,000. And we bind it to set progress on ProgressBar. Yeah, that was the state. That was all the visible state, or our text views and ProgressBar. We can move on to buttons. For buttons, we have three things. First is disabling some buttons, like the next and previous song could need to somehow be disabled when there is no previous song, when we are playing the first one, right? Or the play button has actually different icons because it handles both play and pause action. So we will need to switch them. And of course, we need to execute actions on click. That's the code for disabling the buttons for previous and next song. We first define index in album signal, which contains information about album and an index of currently playing song in this album. We do that. We define that as separate signal because we will use it in two places. We use it to define a previous song signal. Previous song signal it's a signal which contains a song, but this song is optional. When we are playing the first song, then this signal will be empty. Actually, the value will be empty. It will be none. And if we are playing different song, then this signal will actually contain previous song. The same with next song. And then we map it with function isDefined, because in here we only care if this song actually exists, and we bind it to set enabled. This will take care about enabling and disabling these buttons whenever current song changes. To handle icon on play button, we just need to check current playback service state and check if this is playing. So we map playback state to if it's playing, then we map it to pause icon, and if it's not playing, then we map it to play icon, and then just bind it to set image resource on the button. To execute a command, we will use regular OnClickListeners. We could have, like in RxJava, this library which converts a button into a signal. We could do that easily, but we don't need to. We can just use OnClickListeners, and whenever button is clicked, we take current value from related signal. Like in play button, we need to check what's the current state, if we are playing or not. If we were playing, then we will just call pause on service, and we were not playing, then we will get current song ID and call play on that. For rewind and forward, we just get current position updated by 30 seconds, subtract or add 30 seconds, and call seek on service. This is very, very imperative, the same way as we would expect to write it. That's the place where signals are not really functional, but in my opinion, this is more intuitive for developers in Java. Yeah, the same way with handling of previous and next button. We just take current value from the signals containing previous song and next song. These buttons will be then disabled when this value is empty, but due to some threading, it's possible that someone clicks on a button and will get here, but the current value will be empty, and this is handled by this for each. For each will only be executed on a value if it's there, so we don't care. If user somehow manages to click this button, then nothing will happen, we will just skip it. Yeah, the last thing to implement is the ProgressBar input. We could use regular ProgressBar callbacks that we have on Android, and it wouldn't be really funny. And also ProgressBar is not very nice. It's hard to move it sometimes, especially when it's close to other controls. So we can just implement swipe gesture over the whole view. Yeah, let's do that. Handling touch gestures in nice reactive way is quite hard, and it's a topic for completely different discussion. So I will just use a couple helper methods, couple helper classes that I have. First one is touch reactor. This implements actual touch listener of Android. It registers on current view and gives us all the events as streams. Actually, in here, I also combine streams and signals. I just have my own implementation of streams, which is more suited for the way I work, which handles the event context. And I also have custom gesture implementation. This is custom in the way I can compose gestures. I can have click gesture, drag gesture, and whatever else we defined, and we can compose them and add them to a view. In this case, we will just use drag gesture. And we define a couple of helper methods, like the swipe distance creates a signal which contains current distance user swiped from a starting position. Whenever user stops swiping, then it will be 0 or whatever, we don't care. And then duration method just takes current duration, but makes sure that it returns 0 if current duration is empty. Yeah, and that's the ugly method to handle all the swiping. This is actually defining one signal which has swipe position, which is optional. So if user is not swiping, then this signal is none. And if it's swiping, then this is actually current position in the song to where we want to move. This also handles the event where user lifts the finger and we want to move to this position. It calls seek on our service whenever it happens. Yeah, we don't need to go through that. Let's just say it works. Okay, now we actually need to update our UI whenever the swiping happens. We want the user to have a feedback that where he is actually swiping. So we want to update position label and progress bar. And before we used this position second signal in both places. So we will just override that. We need to override that with a version which takes into account the current swipe position. We'll just map over swipe position signal, check if there is something, then we will use it to display. And if it's empty, then we use the previous implementation of taking current position from a service. And we don't need to do any other changes on the UI because UI updating was using this signal. And it works automatically. Yeah, I have a lot of time, so I can show you a demo. This is an emulator. We have an app which implements, it actually has the same view that I showed you. There is activity and a service implementation. It will just take the biggest album that you have in your device and will try to play it. Yeah, it plays something. We can skip, we can go to next song. And we can actually rotate the screen. This rotation is actually recreating the view. Notice that I never implemented any special handling for saving or restoring state. This is done by signals for us. We can rotate the screen wherever we want. And it still works. Oh, and one thing, we can also swipe. We can swipe wherever we want, and whenever we are swiping, position updates itself. When we leave the finger, it moves to this place. Yeah, and that's basically it. All the code, the actual application that I just showed you in this demo is on GitHub. It's on this repo. You can find it there. You can also find the sources for signals implementation in there. This is just a whole project. You can always run it. You can run it on your device or on emulator. Yeah, I actually finished well before time. So we have a lot of time for questions. No questions, great. Okay. Well, the first compilation can take some time. It's obvious, but usually you don't do full compilation every time you have caching, and when you use proper tools like SBT, it's manageable. Yes, I use SBT. This project actually has SBT. You can just call SBT Android run, and it will run everything. Yeah, I hate Creator. No, I really don't like many. Yes, that's exactly what I have in my utils library. Well, I actually accumulated that over years. I started doing Scala like 3 years back, and Scaloid was very ugly at that time. Macroid is still ugly, so yeah. The source is out there, it's on GitHub, but it's not any specific library, there is no documentation. So I would like to, at some point, implement this signal, actually publish the signals as a library, but I didn't have time for that. Yeah, I don't like these libraries because they focus on UI and they focus on doing stuff differently than Android. not really better. They just want to be different. I really like the XML layouts, and that's what they fight with, and that's ugly. Yeah, at the beginning there was this inflate. It was just inflating XML, and all the views below were just calling find view inside. Yes, because they think that XML is ugly, and that's a weird way to go, in my opinion.
How your solution compares to Elixir Java and why you just didn't use it?
Main difference is that I wanted to have all this automatic handling of context, so I can unsubscribe. Well, we just learned on the RX Java there is some project which does that somehow. But actually, Signal is not event stream. In RX Java, you need to represent everything as a stream of events. And this is very unintuitive. Like when you handle a button, then you would like to just register on click and do something in there. But in RX Java, you need to convert it to a stream, and then you need to bind it with something to process some action.